So sorry, I think there was a problem in the link. Please, I hope you can help me pass the message, send the link to your friends so that they can quickly join. Very sorry for that delay. Okay, can you answer me? I hope you can hear me clearly. If you can, you just give me a reaction, like thumb up, something like that. So I believe, okay, thanks so much. Okay, thank you. So let me just wait for like 2 minutes and others so that others can join. Then we'll just continue from there. Yeah. Good evening. Okay, I think I can continue right now. So we are going to look at the we're going to discuss the revision regarding linear algebra one, and I will start as follows. So first thing is that let's talk about the history of a matrix. Then we move on to the next topic, to the next topic, to the next topic, till we are done. Now, the word matrix was not coined for over 4 millennia. Yet the history of matrices goes back to the ancient times. So that means matrix has been in existence for a long period of time. If you're talking about 4 millennia, that should be like 4,000 years. So evidence in the history of mathematics revealed that the existence of magic squares, which is about 4,000 years ago, had perhaps served as the origin of the discovery of matrices. Now, if you can look at it from this side, you see that we have our magic square here. This is a magic square. I think this is 16, 3, 2, 13, 5, and so on like that. So most of the time is that when you had the column together or you had the row together, they will give you the same number. So that's why they mostly refer it to as magic square. All right. Now, so the origin of mathematical matrices lies in the study of systems of simultaneous linear equations, which can be traced to Babylon, and then we are recorded in a tablet dating 300 BC. So we can see that these are just the um, the X-ray. So the Chinese came much closer to the matrices method to solve simultaneous linear equations than the Babylonian through the Han Dynasty. So in that, for the Chinese, there's a book, there's a document called the Nine Chapters of the Mathematical Art. And in this nine chapter, we have the eighth chapter. Eight of it is dedicated to Fancheng, and Fancheng means rectangular array, or what we will refer now to as matrix. So in 1850, an English mathematician, James Joseph Sylvester, coined the term matrix. So the matrix is a Latin word for womb, and then which derived from the matter, mother. So, and is defined as the oblong arrangement of terms. He coined that word womb to treat matrix as a generator of determinant. Now, let me explain one thing there. Yeah. Now, you know that said the matrix is a Latin word for womb, which is derived from matter, and matter is a mother. So when we are talking about mother, definitely a mother will conceive and then carry the baby inside, right? Now, if you look at anytime you see matrix, you can see that it's inside a bracket, a square bracket. So that square bracket is the womb that is carrying the elements. Those elements can be 2 by 2, 3 by 3, 4 by 4, or 2 by 4, and so on like that. So for example, now let me give you, you know, I will explain both conventional and unconventional as long as you understand what I'm saying. All right. Now, let me explain. If you have 2 by 2, for example, maybe 2, 1, 4, and 0. Now, in this case, you mentioned it's 2 by 2. Unconventionally, I can say this is a twin. Yeah, because it's 2 by 2. So a mother can have twins inside, or if it is 3 by 3, that would be like triplets. We have another baby inside. Never mind, I didn't draw very well. Uh, have another baby inside. That is 3 by 3. Now, if you say 2 by 3, yes, maybe out of the three born, out of the three babies inside, only two survived. The remaining one did not survive, something like that. Okay, so I hope you understand what how we come across that the square bracket, which means the womb, and the womb is from the matter, which is from the mother. All right, now let me proceed. Then we have applications of matrices. One of the great qualities of a matrix is the ability to create code in a situation where you need to send a private message to an ally. Now, the concept of matrix militarization was back to Julius Caesar. I hope you must have heard about Julius Caesar, at least. That is 449 BC. So where he will send message to his generals, and in the process of sending message to his general, what will happen is that as at that time, there was nothing like phone and so on. So some of the enemies can ambush the emissary, and then kill and get the message, and at the end of the day, know their tactics. But he usually use a code, even though if you are able to um ambush them, kill the emissaries, and then collect the, what do you call it, the document or the information, it will be useless to you, because there's nothing you can do with it. You don't understand it. It's coded. So here, that is why if you look at WhatsApp, Facebook, everything is being coded. Third party cannot influence, third party cannot get access to it except you have to permit it. So there's a code, there's a now. Can you not hear me? I think you should be able to hear me now. You should be able to hear me now. All right, thank you, Mr. Adinoyi, right? Okay. Sometimes I think it's the network. All right, all right. Okay, so I can continue now. Thank you for that. Okay. So let me now share my screen so that we can continue with that. All right. Okay. So I think I stopped here. If you still remember. Okay, Miss Esther, you cannot hear me. Yes. I think that should be from your side. I think others can hear me now and they can see me. Okay, so let me continue with that. Now, we then have that a square matrix with ones on the main diagonal and a zero elsewhere is called an identity or a unit matrix, and an identity matrix is denoted by the letter I. So we use I for identity. That's why I told you that this course is very easy, very simple. What happened is that we just use the we don't use we use the normal notation identity. The I start the identity, so that is I. Okay. However, if we want to now say the size of the I, it will now be IN. The N is the dimension. So the N here is the 3. So I3 means the identity of order 3. Okay. And remember that an identity matrix is always a square matrix. Therefore, this will be an identity matrix. Now, what happened in this identity matrix? The diagonal. Okay, I will explain what we call the diagonal. This is the main diagonal. A straight line you draw slant from the left to the right. Okay, it's called the diagonal. Now we have one there. Once there is one, and every other element there are zeros. Remember, I explained that the elements are what we have inside the matrix. We can have name of people, or we can have anything can be there. Okay, and then definitely that becomes that is the element we have there. Okay, Mr. Salihu Miriam, I think you can hear me, right? Salihu Miriam, don't know, or you can see me. That might be from your own side. All right, let me continue, please. So, so in this case now, we then have the our identity. So you understand how we will get this identity I3 to be this. Now another one is square matrix in which all the entries except the main diagonal are zero. Is called diagonal matrix. Now we have identity matrix I, diagonal matrix D. What is the difference between the two? They look alike. However, the difference is that in the diagonal matrix, can you see the diagonal part here? The diagonal part here. This diagonal is not one. The entries there are not one. There are many. They are different from one, sorry. Like 2, 3, 4. So that is a diagonal. But if it is one that is there, that becomes an identity. But if it is not one, it becomes a diagonal matrix. Now, what is the difference between the diagonal matrix and in the diagonal matrix that both of them, you see the identities are one throughout. Diagonal is any other number but not one. However, the numbers that must be there must also be the same. You see that if you have 3, 3, 3 there, sometimes maybe for 2 by 2, you can have 5, 0, 0, 5 for 2 by 2 diagonal. You can see what happens that in the diagonal, the entry is not one, but they are the same. So don't mix it up with something else. Diagonal is not one, but the entries there are the same. Identity is one, and they are the same too, right? All right. Now, let's look at another one. A square matrix is said to be lower triangular if all the entries above the main diagonal are zeros. You see in this case now, if you come to the diagonal the diagonal aspect here, you see that above it there are zeros. Now another one you call the upper triangular matrix, that is for the lower. But in this case now, look at the diagonal part here. Below the diagonal, everything we have below is zero. That becomes upper triangular, because if you look at it now, it forms a triangle but in an upper form. This one forms a triangle but in a lower form. That's why we call it lower triangular matrix. Now, two matrices are defined to be equal if they have the same size and their corresponding entries are equal. For example, we have this matrix now. You can see that does A equals to B? Well, it's only equals to B if and only if our X is equals to 5. But if it is not 5, they will not be equal, because the first entry here is 2, the same as this. The second entry is the same as the second entry of B. The A21 is the same thing as A21 here, and this one should be the same in order for it to be equal. Now, if we start out with a matrix n by n and then we try to cross out some of its rows and columns, we obtain what we call a submatrix. A matrix, another matrix inside a matrix is called submatrix. All right. Now, for example, now if you cross the second row and the third column, we are going to have 2, 3, 2, 4, 1, 2. Now, what do we get if you cross out last row and first row? The last row and the first column, you can see. What do we left? What we are going to have? We are going to have this one, because we have crossed out, and you can see what we got here. So if you cross out that last row and the first column, we are going to have this matrix. This is sub-matrix. Now, don't worry, we're still going to look at this sub-matrix, a kind of a sub-matrix, when we get to the determinant under reducing. Now, we can partition matrix into submatrices. You know, the first one we did was only one submatrix, but here now we can partition it into submatrices. So when you want to partition, you insert a horizontal and vertical lines. So you can see the first the first vertical line, which is at 1, 2, 3. That is a third column. After third column, before the fourth one, that's where we have that blue line, dot, 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 dot. Now, if I put another line after the second column, after the second row, now you can see what we have. Now, I have divided this matrix into 4 parts, although they are not equal, but into 4 parts. The first part is this place, this. The second one is this. The third one is this, and the fourth one is this. So now we have already partitioned this into different 4 parts. Now let's see. Okay. We can also partition, if you take the first, after the first column, and then after the first row, you can see that we have another 4 also. The first part is 2, ordinary 2. The second matrix, submatrix again we have is 2, 3, 2, minus 2. The third submatrix we have is 0 and 4. And the fourth matrix we have is 3, minus 1, 6, 1, 5, 2. Okay. In this case, now, partition can be carried out in many ways. So it all depends on what we are given. So the submatrices can be written together as elements of this. Now, because the 2 is a matrix on its own, because we try to like divide the larger matrix into smaller matrices. So the A11 is actually 2. A12 is 3, 2, minus 2, as I mentioned. So you can see it here now. So this is how we get our submatrix. So we can see that our 2, which has formed a submatrix, which is A11. Now the next is the second one, which form A12, and the third one, which form A21, then the last one, which form A22 in this case. All right. Now, let's talk about matrix operations. If A and B are matrices of the same size, then A plus or minus B is this matrix obtained by adding or subtracting the corresponding entry. So we can add two matrices together, but there's a catch there that you have to know. If you're adding two matrices together, they must be of the same size. That's why you can see that same size is being put in blue color, that it must have the same size. Now, for example, we have this A and B. They are 3 by 3. So we can add the two together. Now you see the addition. What if you do much subtraction, A minus B? For the addition, you add, we'll call it element wise. You add it element wise. So 7 will be added to 8. You can see it here. Minus 2 will be added to 5. You can see it here. 5 will be added to 0. You can see it here, and so on. So now if you do that, you get this one. And if you do for A minus B, you also get this one. But we can also do B minus A, okay? And you can also do B plus A, okay? Now, one thing is that A plus B is always the same thing as B minus A. However, B minus A is not the same thing as A minus B, please. Now, if you say, oh, why? is very simple. Let's say B is 5 and let's say A is 2. Now, 5 minus 2, is it the same thing as saying 2 minus 5? They are not the same. So in this case, B minus A cannot be A minus B. But if you say B plus A, it can be A plus B. I hope you understand this. Okay. Now, this slide is not correct. Which of the slide is not correct? John, you are not seeing the example. Okay. You are not seeing it. Wow. Okay. Let me reshare. Let me reshare. Because the thing is, let me reshare. I believe you can see this one clearly. If it's not displaying, are you sure? Because my network is actually strong here. Okay, you couldn't see from diagonal matrix. So that means you are saying I should go back to diagonal matrix. Is that okay? Okay, it's not displaying now. I think if it's not changing or it's not displaying, possibly it might be your network. You can just reload. You know what we do? Click on click on it and reload. Okay, like you reload, you refresh, then it will definitely uh, be in the correct position because everything here is okay. Okay, just try to refresh the page because sometimes network can cause that. So just refresh. Once you refresh, I think definitely you're supposed to have the okay. Everybody's now seeing it. So please just try to do that. Okay. So that means I can continue now. Yeah, if the change is not reflecting, please what you have to do is just refresh. Once you refresh, definitely it will keep to the date, to up to date. Possibly you are using this for the first time, that is why. So it will definitely keep up to the place. Can I start from which place? From this place. Which place? Yeah. Cecilia, I hope you can hear me. You said I should start from this place. You mean from the matrix operation? Okay. All right. Okay. Now, let me start from this matrix operation back. Um, okay. Everybody is saying matrix operation. So let me continue from there. Now, for this matrix operation, what happened is that we can add two matrices together, we can subtract matrices together, we can multiply. However, there's a catch there that you have to figure out. If not, you will make a mistake. First is that if you are adding matrices together or you are subtracting, they must be of the same size. That is why if you look at this, you see that what I did was same size. You can see this blue color, same size. That means it must have the same size. If it's not the same size, you can't. For example, now if you look at this A now is 3 by 3. This one will also be 3 by 3. This 3 by 3, and the other one is also 3 by 3. So you can add it up. However, let's say there's another matrix C, for example, and I have for C is 1, 2, 3. Let's say minus 2, 5, 7. I can't add A cannot be added to C. No. Why? The C is how many? Is 2 by 3. Please, do you understand why it's 2 by 3? We have two rows, that is 2, by then 3 columns. So 2 by 3. this 3 by 3, you can see A plus C now. There's no way you can add 8 plus 2 because 3 by 3 plus 2 by 3, they are not. Okay, for example now, let's add it up. 7 plus 1, right? No problem. 8, right? Minus 2 plus 2, that is 0. You say, okay, it's still correct. Now, 5 plus 3, 8 is still correct, no problem. 0 plus minus 2, that is minus 2, no problem. 8 plus 5, okay, 13, no problem either. Then minus 1 plus 7, that is 6. Okay, now these 2, that 2, 6, and where are we going to add it to? There's no other element left in C that we can add it to. So that is why that you can't add 2 or subtract 2 matrices if they don't have the same size. They must have the same size for you to subtract. So that's what we have there. Now, we can add, we can subtract. For example, when we added this one together now, we got this. When we added this and this, we got this matrix. Now, we can also subtract A minus B. A minus B, you subtract the two of them, okay? That will be 7 minus 8. That should give me minus 1. Minus 2 minus 5. That should give me minus 7. 5 minus 0, that should give me 0, and so on like that. So you have this, okay? Now, next is that we have if an n by n matrix is we have n by n matrix and alpha is a scalar, then the product of alpha A is the matrix obtained by multiplying every element of A by alpha. So if you have A to be this, and then we can compute 3A. The 3 is the alpha there, and which is a scalar. So that means you are using this 3 to multiply all elements in A. And if I use the 3 to multiply all elements in A, I will get 360 minus 3. So we have that. Now, if A is an M by R matrix and B is an R by N matrix, then we can find a product. Now, please, you have to pay attention to this product. Very important. All right. Now, we can multiply, but there is a catch there also, that if you want to do that, there must be something for you to do. Okay. Before I move to that, it's still not displaying. Okay. Okay, as your C is not showing, please refresh. If it is that, refresh. For those staying at Filele, sometimes network usually have issue there. Please refresh if you can't really get. Please refresh. All right. I believe I can continue now. If I can continue, someone should give me a thumb up. So I'm waiting for a message. If I can continue, someone should just give me a thumb up. All right. Cecilia. Oh, okay. Thank you. Thank you. So let me continue now, because that part I'm moving to now is very, very important. Now, let's say the next one. Now, when you multiply the corresponding entries from the row and then columns together, and then we add up the resulting products. So when you do that, you are going to add it up. Now, there's something you have to know, that the product of A with B is possible. That means it's defined if and only if the numbers of columns of A is the same as the number of rows of B. I will explain this one. Then the product is defined if A and B are matrices of the same size. Now, it doesn't mean that you can't have two matrices that have not having the same size. You can, but you have to pay attention to that. However, if the matrices have the same size, for example, we have 3 by 3. If you have 3 by 3, maybe A is a 3 by 3 matrix, and B is also a 3 by 3 matrix. No need of you racking your brain at all. You can multiply the two together. However, if you have A to be 2 by 3, and then B to be maybe 3 by 2, you don't know yet. There's something you will do to check. How in this case it can multiply, but I will tell you how to do that. Now, for example, if you have m by r matrix and r by n matrix as matrix B, so we say A is m by r and then B is r by n. Now, sorry. So we have m by r and the r by n. Now, in this case, what we are going to do now is that we will look at the inside, that is called the inner part. So if you write A, you know it's m by r and B is r by n. So the inner part is the r. Then the outer part is the outside. Now, when you do that, you check if they are the same. If the inside is the same, then you can multiply A and B together to give you m by n. If they are not the same, you cannot. Now, let me give you an example. For example, we have that A to be 3 by 3. Okay, 3 by 3. And then B to be 3 by 5. Okay, now, in this case now, the inside is 3, right? Then the outside is 5. You can see that this is 3 and 3. That means it can multiply. However, if this inside or the inner is they are not the same. If they are not the same, therefore it cannot be multiplied. And if it is not, if you cannot multiply, you say undefined. For example, now you see this one, B is r by n and the A is m by r. Now the inside is the last one we have here. Compare it to this first one, right? Now they are not the same. M is not the same thing as n. In this one cannot multiply. So that is why we are asked that is BA defined? No. Why? Because what we have, remember, okay, let me go back to this one here. That is it. Now remember that this is row times column, row times column. So what we have last there will be the same as the first of this one. If it is not the same, you cannot multiply. If they are the same, yeah, you can do. You can multiply. Let's look at an example of that. Let me see if there's some all right, everybody. This yes, no, I'm displaying the question. Definitely. That must be from your end. If I don't make mistake, I think the why you are not catching up is from your hand. Please refresh that if you cannot. Okay, thank you. Let me continue then. Okay, now please everybody pay attention to this. Now we have this. This is a 2 by 3 and the B is 3 by 2. I hope you understand this. Okay, I believe you do. Oh, sorry. This is a 2 by 3, 2 by 3. And this is a 3 by 2. Now, before I continue to display that, let me A is 3, sorry, not 3, 2 by 3. Then B is 3 by 2, right? I've written it like this. Now, the inside is this. Those two that are close to each other. They are the same. Good. I can multiply. Okay? I can multiply. Now, let's now say they said B times A. You can have A times, you can have B times A. I'm not saying they are going to give you the same thing, but let's do B times A. B times A is 3 by, B is 3 by 2, and A is 2 by 3. Oh, it seems this one can also multiply because the last one here with this first one here are the same. Hooray! We can still multiply this one too. All right. Now, what are we going to have our answer? What kind of dimension, the size of the matrix we are going to have as our final answer? The final answer will be based on what we have here left, 2 by what we have here left, 2 by 2. So that means AB, when we multiply AB together, we are going to have 2 by 2 matrix. It's not going to be 3 by 2 anymore, or 3 by 2, 2 by 3. No, no, no. In this case, let's look at this one. What will be our BA? Our BA here will be, what is left here is 3. And what is left here is also 3. 3 by 3 matrix. This is what we're going to have. Now, let me erase this and let's look at the way it's been done. Please, if there's any question, definitely, please, you do ask. And I know there will be a question. Is the product A B defined? Can we multiply A and B? That's what I just did now. Yes. Then if yes, what is the size of the resulting matrix? Now, A B equals C. Now, do you know why A B equals C there? We say A B equals C. We don't want to be saying A B A B A B together again. So let's, if you say A B A AB equals C, meaning that the another what the other matrix we get, let's name it another, let's give it another letter. Don't let us say AB. Let's say it's C. That's why we have C there. So that C is a capital letter. Remember that every matrix we have should be a capital letter. So and then the element inside the matrix should be small letter. So we have C11, C12, C22, C21, C22. I hope you understand how we got that one. Because when I did that one, when I try to multiply the two of them together, that is the A and the B, you remember that this is 2 by 3 and this one is 3 by 2. And when the inside cancel out to show that, okay, definitely we can multiply, the resulting one is 2 by 2. That's how we have this 2 by 2 here, matrix. And for a 2 by 2 is, if you are using letter C, that will be C11, C12, C21, C22. If you are using letter D, for example, capital D, then this will be D11, D12, D, and so on like that. All right. Now, we have this. Now, let's now multiply. This is what I want to explain. Now, let's calculate C11. Now, how do we get this C11? C11 is this. Please pay attention. I'm going to explain this to you now. Okay, I'm coming. Let me use my C11 is this. C11, remember that it is A and B that is multiplying that is giving us another letter C. This C11 means that this one it has its origin from A, and this second one has its origin from B. Likewise, this C12, this one has origin from A, the 2 has origin from B. C21, the 2 is from A, the 1 is from B. C22, the 2 is from A, the second 2 is from B. So now, I would like to, there might be question that people you want to ask. Which one? Okay, James. Okay, from Oma, let me read that. How about the simultaneous equation in a matrix? You didn't explain. We have not gotten to that. We still have some to do. Definitely, we will do that. We will do that. All right. Now, what I'm saying here is that this C11, this one is from the first part here, the first row. So that's why we have this one here. And the second one here is from the first column. Remember that anytime you have maybe D21, it means row column, right? Now, you can see it here. Now, we can then multiply. These 3 can multiply these 2, giving me 6. This minus 2 can multiply this minus 1, giving me 2. Then this one multiply this minus 3, giving me minus 3. That's what we have here. When you add it together, we got 5. Now, let's look at another one. C12. C12, the 1 is still the first row of A, the 2 is the second column of B. So in this case now, this comes here, and the second column of B is this. So because that 2 we have here is column, this one is row, but the row here you have to go to A. The column here you have to go to B. That is meaning. All right, now, so let's continue. let's do the next one, which is C21, right? C21. Now, C21 means that the row of A and the first column of B. So we're going to have this. Then the last one is C22. That means the second row of A and the second column of B. So let's see. C22 is second row of A and then the second column of B. Now we can multiply those one together and see what we are going to get. So 0 times 4 will give me 0. 4 times 3 will give me 12. I'm adding it up. Minus 1 times 1 will give me minus 1. So if I do this one, I should get 11 in this case. So let's see. Now, definitely we are going to get 11 in this case. All right. So we see that C22 is now 11. So after getting this, we can then put them together in a matrix form since it's 2 by 2. Okay. And not the right, Andrew. Sometimes it is not the mouse that will touch it. Sometimes it has been programmed. It is the arrow. I should move my screen to the upper corner. Okay. Desmond, what happened? Matt want to kill you? No. Well, I think that is the way YouTube did that. That's to come down. I was not able to do. Okay, someone said I should come again on this part. Okay. Now let me come again so that everybody see. Please, if you can see hear me, if we cannot really refresh and then I'll come again on this multiplication. Please, you need this multiplication very well. Okay. For those that are online, you need this multiplication. Okay. Please. Let me re-explain this part. All right. In multiplying um, two matrices, after you have figured out whether they can multiply or you cannot multiply, the next thing you have to do is, okay, let me now multiply it. If it can multiply, then you have to start the multiplication. How do you even start the multiplication? You start the multiplication in this format. Remember that when this A and B multiply each other, we are going to have AB, and that AB, let's call it C. Let's call it another letter C, so that it will not just waste our time. C. And if it is C, that means, and you remember that this C is 2 by 2 based on the A and B multiplication, that this is 2 by 3, and this is 3 by 2, and the 3 and 3 cancel each other, pim, pim. That shows that we can multiply, and it left with 2 and 2. That's how we have this 2 by 2. And 2 by 2 matrix is 1 1 based on C. If it is D, you do D1 1, D2, D1 2, and so on like that. Now, but we have to calculate what is the value for C11. Now, please listen. C11, the value it will be this. This first one, remember that this first number you have is the row. The second one is a column. That is normal matrix. If you have A11, the first is row, the second one is column. Even if you have A43, for example, this 4 is row, this 3 is column. That is the way it's being done. Now, C11, it means that row 1, column 1. This row 1, which one are we even talking about? Which row? It has to be the A. Remember that the question is A, B. It is the A that comes first. So that means the row go for A, the column go for B. That's how you do it. Now, if it is BA, it's another answer you get. C11 is going to be the row for B, the column for A. I hope you understand. Okay. Depending on how the question appears. I will re-explain this one again. I will re-explain so that you understand and you know how to do it in case you see it. Please pay attention. So my C11 now, it means row A. That one represents row 1. the C1, 1 there represent row 1. Row 1 of A is this. So I'm going to write it down. Then the second one here represent column 1 of B, not row. Column 1 of B. So that's I C1. So in that case now, you can see how it is. You can see the arrow come down. Then for the column of B is this. Now, after that, you can then multiply. 3 multiplied 2, that should give me 6. Minus 2 multiply minus 1, that should give me 2. 1 multiply minus 3, that should give me minus 3. Add everything together, all your answer, you get 5. Let's say another one. C12 means that this is the row 1 of A, but these 2 represent column 2 of B. You can see column 2 of B comes here. Column 2 of B comes here. So in this case, this is how you do that. I will explain. This one is the, remember we are doing AB. So this one is the row 1 of A. This 2 is the column 2 of B. You can see it. And for this one, you can see it here. Now I can now multiply. 3 will multiply 4. That will give me 12. Minus 2 will multiply, sorry, minus 2 will multiply 3. That will give me minus 6. Then the 1 will multiply 1. That should give me 1. Add everything together, I'll get 7. That is my value for C12. You also do the same thing for C21. Then you also do the same for C22. Okay? And when you do that, for the C22, you should know what to get. C22 is the second row of A and the second column of B. So in that case now, we were able to get 11, because it's easy to do. 0 times 4 is 0. 4 times 3, 12. Minus 1 times minus 1. Minus 1 times 1, that is 1. So that is 0 plus 12 minus 1. That is 11. That's how we got that 11. Okay, I believe you all understood this one now. Yes, the video will be here on YouTube. He added what number? When you do that, you just add all these numbers together, and that is all. Okay. I believe I can still continue. If I can continue, give me thumb up. Give me thumb up if I can continue. Say someone should give me thumb up if I should continue. All right, football. Thank you. So let me continue now. All right. Now we have a square matrix. Okay. We have a square matrix can possess positive power. So we express that result in multiple times of the power of A. For example, A raised power 2, A raised power 3, A raised power 4, and so on like that. Now, let's evaluate A raised power 2. If A is 3 minus 1, 0, 2. This is simple to do. What we have to do is, remember that if you say A square or A raised power 2 is A times A. That's what it means, right? Now, what size is A? A is 2 by 2. Please don't say you don't. This is 2 by 2, right? The another A again is 2 by 2. Definitely, I can multiply, right? Inner. Yes, good. I can multiply. Then the resulting, what I'm going to get is also 2 by 2. 2 by 2, right? Okay. Now, I'm going to get 2 by 2. Now, but after that, let me now show you how we multiply that. So, if I say A square, that means my A times my A will be 3 minus 1, 0, 2 times another 3 minus 1, 0, 2. Now we have this, right? When we have this, let's multiply. Remember that this will give you another matrix. Okay, what matrix should we call it? Let's call it B, right? Let's call it B. Okay, I'm coming. Let me erase this. So let's say the A times A should give me another matrix. So let's say give me B, for example. And you know, well, our B is 2 by 2. That is going to be B11, B12, B21, and B22. Okay. Now we have this. After we've gotten this one now, what would be the next thing to do? Let's calculate our B11. B11 means that this first one means the row of this one. That is the first row of this, which is 3 minus 1. The second one here means the column of the second one, the first column of the second one. So that is going to give me 3, 0 like this. Now, please pay attention. If you don't still understand, you will see another. We have not done yet. Now, let's now multiply. The 3 will multiply 3, right? That is 3 times 3. Plus the next one, the 0 multiply, sorry, the minus 1 will multiply 0. That is minus 1 times 0. That should give me 9. Okay, 9 plus 0, because minus 1 times 0 is 0. 9 plus 0, that should be 9, right? Okay, so here, let's put our matrix here. We have gotten the first one, 9. Let's do the next one, B12, right? B12 should be, this one here is the first matrix. The second one is the second matrix. You know that we have two matrices now. But this one represents the first row of the first matrix. First row of the first matrix. These two represent the second column of the second matrix. This is second column. So we are going to write that one. That is 3 minus 1, and then minus 1, 2. Okay. Now we have this. Let's multiply it and see what we are going to get. Now, that means my 3 here will multiply this minus 1. That is 3 times minus 1. Then the next one is this minus 1 will multiply these 2. Okay, that is plus, plus minus 1 times 2. Now, 3 times minus 1 should give me minus 3. And then the other one will give me minus 2. Okay, the answer is minus 5, right? So I'll have my minus 5 for B12. Now, it remains B21, right? I will do the next one, B21, so that you all understand what I'm doing. Then you will now, okay, let me first do B21. B21. I'm coming, I want to erase this. All right, now B21, B21. These two represent the second row of the first one. Why this one represent the first column of the second one. Okay, in this case now I'm having 0, 2 multiplying 3, 0. So let's multiply. 0 times 3, 0 times 3. We add it up to 2 times 0. Okay, I think that should be, that is 0 plus 0. Okay, 0 plus 0 is 0. Okay, we got 0 here. So now we can see it's 0 here. Okay, now the next one we'll do is B22, right? Okay, so let's do B22. Now, I'm not going to do B22 for you. Let me keep this one. Okay, I will not do B22. I want you to try B22 and just give me the answer right now. Oh yeah, Buchi, you said you are not seeing anything. That might be from your side. That might be from your side. Okay, let someone answer DJ Sonny. If you see that it's not changing, just quickly refresh only. It will solve the same. It will solve the problem. Okay, if you can hear me and you can see it clearly, can you just give me a thumb up? No, no let's wait a little bit for them so that they can refresh. Noah, yeah, you said next page, but your network is really good here. If it is taking too much, it might be from your network. If you refresh here on and you are still having the same epidemic, you're still having the same issue. I don't really know. I believe your network is strong there. Okay, Subtech, you can hear me. Subtech is using a good network. So possibly is the network that is causing that. When my own network causes once I have to switch. And since then I have no problem. Okay, Andrew, I think I can see. DJ Sonny, you are now telling the truth. Is the Filili network that is not really okay there? I think so. Yes, I'm showing you the page. It's displaying. Is it not displaying? If I have to cancel I'm sharing my screen. I'm sharing my screen. I can even see my screen from the YouTube directly here. If there's a problem, it should have notified me. Okay, you don't know how I got to the answer. All right. Okay, okay. Salami, you two, you live in Bisola. Okay. I don't know. All right. If you want me to re-explain this, I will re-explain this. No problem. But refresh. Okay. So that will not really delay us too much. So what we did here is that okay, you can see the final answer, but let me explain. Let me re-explain this side, please. Where's my? So let's use the eraser. What I did here, very simple. Um, we want to evaluate a square. That is a times a twice. You write it two times. After writing it two times, the reason why I'm trying to re-explain this so that you understand it. After writing two times, the next thing you have to do is that you start the multiplication. So since what we're going to get is 2 by 2, so let's call that 2 by 2 b1 b1 2 b2 b2 So let's calculate b11. For example, now let me just go to this b21 that is already written here. B21 means that this 2 is the second row of the first matrix. This one is the first column of the second matrix. Now, this first one always go for the first matrix. This second one always go for the second matrix, okay? The first number you see is for first matrix. The second number you see is for second matrix. Then this first one you see here is row of the first matrix of A. While this one is column of the second matrix. So let's say another A, but another different one. So definitely, if when I'm explaining, let me erase this. Uh, okay, sorry. So it's another thing. Yeah, so it's eraser. So we have this. Let me give you one example. Now, for example, I think have we done that? Let me see. Um, Given A. Okay, let's do another one. Let's do another question. I think there's a question. Okay, I will do an example. Don't worry. There's an example somewhere there again. Now, we have what we call inverse. Inverse. We can do inverse. We can calculate the inverse. Inverse of a matrix is usually from what do we call it? From a square matrix. So it's only a square matrix that can have an inverse. But I'm going to explain this inverse when we get to the terminal. So I will not talk about this one yet. Okay, we'll do that when we get to determinants. Then we have what called transpose. A transpose of a matrix is simple. You are turning the row, this row, this row, and this row. They will all become column. Turn this row, just like you are turning your phone. If you turn your phone side, not upside down, but just side way. These 2 and 3 will become like this, 2, 3, vertically. This 1 and 4 will be vertical, 1 and 4. This 5 and 6 will be vertical, 5 and 6. That is just transpose. You turn rows to columns, and that's all. Then we have another one called symmetric matrix. So a symmetric matrix is that if A is equal to A transpose, you the original matrix itself, if you transpose it, you are still going to get the same thing. That is called a symmetric. But if you transpose it and you get something different, especially with a negative minus A equals minus 80, then that one becomes a skewed symmetric. So all main diagonal entries of a skewed symmetric matrix must be zero. The main diagonal, the diagonal must be zero. So for example, we're still going to do multiplication of a matrices, don't worry. Now, if A is a square matrix, then we can find a trace. Yeah, this trace is very important. Denote it as TRA. So the trace is so simple. First, it must be a square matrix. Second is that you just go to the diagonal, add all the numbers together. For example, for this one now, the diagonal there is -1, 5, 7, and 0. Let's see. You can see -1, 5, 7, and 0. Add all of them together. That's 11. That is all. That is the trace. Now, let's look at this one. For those that want to look at example of a multiplication, so I'm going to use this one to explain. All right. Now, you can see it here, but I'm going to explain. If A equals it, please pay attention. Okay, let me go back and then see ask if all of you are still with me. Okay, the page. Okay. Yes, I'm doing it one step by step. Ask me when I'm going to do RREF. I think after this is a linear system. Is not much. Then RREF, then determinant. These are just 4 topics we have. Don't worry. I'm almost done with this one now. Okay. Thank you. Yeah, the video will be available for download after. Okay. Now, let me explain to you. Please pay attention. Now, for this one, you see that I'm laying emphasis on this as kind of example now. If we have this, we want to compute trace of a square. There are two things you will do here. You will do a square, you multiply a by a. After getting it, then you are still going to find the trace of it. Now, a square first. A square is this and this. We are multiplying the two together, right? Let's do the multiplication before we find the trace. Multiplication is this. The multiplication will be 2 by 2, right? Now, let's say the multiplication give us b, and b will give me b1, sorry, b11, b12, b21, and then B22. Okay, now we have this one. Once we have this, what will now be the next thing? Let's calculate our B11. Let me calculate B11 here. B11. Please remember that this one here represents the first matrix. The row of the first matrix, that means the first row of the first matrix. This second one represents the column of the second matrix. So this one is for this row of the first matrix. Then this one, the second one, is first column of the second matrix. Okay, so that's going to be 2, 0, and then the other one is also 2, 0, but vertically like this. Now let's multiply this one. I don't want to waste my space. That will be 2 times 2, 4. Then 0 times 0, 0. So I'm going to get 5. I'm sorry. I'm going to get 4 here. I'm very sorry. Now let's do B12 now. B12, let me erase something here so that you can B12, let's do B12. B12 means this one is the first row of the first matrix. These two means the second column of the second matrix. So therefore, I'm going to have 2, 0, 0 times 0, 0 plus minus 1. Oh, that is minus, that is 0 also. That will give me 0. Okay, B21. So for the B21, what this one means is that these two is the second row of the first matrix. Second, that is why they have to mean second. This one means the first column of the second matrix. So I'm going to have 0 minus 1, then 0 minus 1 and then 2, 0, right? 2, 0. Okay, so that should give me 0 times 2, that should be give me 0. And then this 0 minus 1 times 0 is 0. Oh, okay. I got 0 here. All right. So that means in my matrix, I'm not yet done. The first one is 4. The next one is 0. The next one is 0. And the last one, I think you can do that last one. But if you do that, okay, let me still try it. So that, we're wasting much time on this so that we can move to the next one. So if you do the next one, B22, you're going to get 1. Now I've gotten a matrix. From this matrix now, I can now find my trace. And the trace says, go to the diagonal, do it like this. Add all those elements in the diagonal. The elements in the diagonal are 4 and 1. I will add them together. 4 plus 1, 5. Okay, 5 is the answer. So I hope you pay attention more on this, right? Okay, so can I now continue? Yeah, Salami. I have to Bisola. Yes, I have to explain step by step so that you understand. You understand the ref. Now, I hope I can continue. Okay. So now, okay, another one before I move to the next topic, please. Before I move to the next topic, pay attention, please. Giving A to be this and B to be this. The A is 2 by 3 and the B is 3 by, depends on you now, or I should just um, Okay. So, okay. For those that are online, I think you're all okay. Yeah. I think I buy that idea too. So we can just finish this one, then uh, we do linear system, RREF, next one. The linear system is not something as I just feel one there, but the RREF, yeah, I have to explain that one deeply. Let me see. Okay. Mm. The PDF is, they all have the PDF. So your that means you have not attended before. Okay, so let me finish up this one according to what you all said. Aaron has a course prep. He has the on Google Classroom, so everything is there. So now let me finish up this last one. I think that is the last actually. Yeah, it's the last one. Before you can see is the linear system that is next. So let me just finish up this one, right? You see that the next is the system of linear equations before we continue. But here, um, I should just finish up this one. Okay, so I should just finish it up, right? If so, just give me a thumb up and let me finish it up. So that the next we start with system of linear equations and the Harari F. Okay, Jimbas. Okay, okay, you all agreed on that. Okay, now let me continue then and explain this one. Now we have these two matrices, and then we want to know if A and B is defined, if the product of AB is defined, the resulting the B does B inverse exist, and then does a trace of A exist. Now the first question is A and B defined. But before you know that whether A and B is defined, what we have to do is that let's write the A and B out first. A times B. A is 2 by 3, and B is 3 by 2. I believe you all understood this one. And to know whether it multiply, it is this first one with this one, the last one and the first one here. They are the same. Good. Is defined, right? Okay. Okay, before that, sorry, we have to use A plus B first. Now, for the plus, it is not defined because this when we are talking about plus or minus, when you're adding or subtracting, initially I said that they must have the same size, but they are not the same size. Therefore, it's not defined. You can't add A and B together. Okay, if you say y, add this -3 to this one. Okay, it can be added, right? Add this 6 to this -4. Yes, it can be added, right? Add this 7 to what? To what? We don't have anything here to add it to. So it's not possible. The same, 1 can be added to 1. 0 can be added to 8. This -1, where will it be added to? Nothing here. Okay. Then this last thing again. So there's no way we can add up this kind of two matrices. It's not possible. So it's not defined. Now the product, is the product defined? Yes, let's see whether the product is defined. The product is defined because we have done it here. Okay, we have done it that 3 and 3 are the same, so it can be. Then what is the resulting size? The size is this 2 by this 2. This is the size. The size is 2 by 2. Now, does B inverse exist? Inverse, trace, the two of them, they they deal with square matrix. Square. Let me just write it properly. Square matrix. Okay. Now, the inverse of B, this is inverse. That is B raised by -1 is called inverse. We'll do that when we get to matrix. B inverse, the inverse of B. Let's go to B. But this, so there's no way. The inverse does not exist. Why? Because it's not a square matrix. Next one, trace. You know we did trace, the diagonal. The trace also go with square matrix. That's the trace of A. A is not a square matrix. Therefore, there is no trace of A. It does not exist. Why? It's not a square matrix. Now, before I would like to do this multiplication. For those that are just continue, check, just watch what I'm doing. Let's multiply A and B together. Should we? Okay. Now, we know A times B, right, is 2 by 3 and 3 by 2. Okay, we say we can multiply, right? And the resulting is 2 by 2. So let's call that one A and B. Let's call the letter C. C is a 2 by 2. I know what C is going to be. C11, C12, C21, C22. Now let's calculate which one first? C11. I believe you understand what this one means. This one means you go to the first one we are multiplying, which is A, but row 1. That is the meaning of that one. This second one means you go to the second matrix that we are multiplying, but what number? I mean, what column? Column 1. Okay, so that's going to be -3, 6, 7 by 2, 1, 3. Now, in this case, let's multiply that. -3 and by 2, that is -6. 6 times 1. I hope you can understand what I'm saying. 6 times 1, that is 6. Then the next one is 7 times 3, that is 21. I think that the answer will be 21 here. Now the next one, let's do C12. C12, this, okay, let me erase. C12, this one is the first one, the row 1 of the first matrix. This 2 is the column 2 of the second matrix. So now I'm going to write -3, 6, 7, then by -4, 8, -1. Now let's multiply this one together. -3 times, that is -3 times -4. I hope you understand what I'm doing. This first one, multiply this first one. This second one, multiply this second one. Okay, that should be, you can bracket it if you want. That will be 6 times 8 plus, then the next one will be 7 by -1. That is 7 by -1. Okay, I think this one should give me 12 plus 48 minus 7. Okay, 12 minus 7 is 5. 5 plus this is 53. So we have 53 for this one. So now you know that our C, now we have been getting values 21, 53. So the next one is C21. Should we do that one too? C21. I will do C21, and possibly maybe you will then do the C22 for me. So let's do C21. C21 means the second row of the first matrix, and this one means this first column of the second matrix. So that is going to be 1, 0, -1, and this is going to be 2, 1, 3. So let's multiply that. 1 times 2, that's 1 times 2, plus the next one is going to be 0 times 1, plus the next one is going to be -1 times 3. Okay, that will be 2 plus 0 minus 3. Oh, that should give me -1. So -1 here for the second matrix, for the second part there. Now the last part, C22. I believe you can do C22 for me, right? So before we stop today, can you do C22 for me? Yes. Oh, okay. Can you do C22 for me and tell me the answer? You only see my face. How come? Okay, you miss everything. I should re-explain. What we have is this question. Okay. Then we want to multiply, we want to subtract, sorry, we want to add up, we want to multiply. Does this and that one exist? Okay. What, oh, sorry. What I'm saying here is that A plus B is it defined? It can only be defined. We remember that we can add or subtract two matrices if and only if they have the same size. The size of this one is different. A is 2 by 3. B is 3 by 2. They are not the same. So you can't add them together. It's not possible. So is it defined? No. Capital N-O. No. Now, is the product defined? The product is defined if this and this are the same. Yes, it's the same. Good. So the product is defined. Yes. What is the resulting size? What are we going to have left if A and B can multiply? A can multiply. This is 2 that will be left, and this 2 will be left. That will give me a 2 by 2 matrix. The next one is inverse. B minus raised power minus 1 means inverse. This is trace. Now, B, anything inverse. Okay, let me just write inverse and trace. Both of them go with what we call square matrix. Square matrix. Let me write that SM. Square matrix. Now, let's see. The inverse of B. B. The inverse of B. Let's see B. B. Is B a square matrix? No, it's not a square matrix. This is 3 by 2. It's not a square matrix. So inverse cannot exist. Does inverse exist? No. Why? Because it is not a square matrix. 2. The D. Does trace A exist? Let's go to A. This is A. That is 2 by 3. And A is not a square matrix. So since it's not a square matrix, there is no trace of A. Remember that trace is diagonal. If you do diagonal here like this now, what happened to this minus 1 here? Okay, so the trace does not exist. And why? Because it's not a square matrix. Now, since it's not a square matrix, the next thing you will now do that, let's multiply that one that is defined, that product, that question B. Let's multiply them together and see what we are going to get. I believe now that everybody can now see. No, I think you can all see now. Or is there anybody that cannot see it again? The solution is not still showing. Okay. Since all of you can see the solution and it's displaying here, I think we will call it. Okay, someone has done it. 622 is equals to minus 5. Okay. Aaron can see it too. Andrew, you cannot still see it, but others can see it and they are getting the answer. Martins, my solution is not showing. Where is the C22? No, I didn't do C22. I only said you try C22. I didn't do C22, but someone did the C22 and said the answer is, oh, sorry. The answer is -5. I don't make mistake. To do this, we are multiplying. Remember that C is C11, C12, C22, sorry, C21, and then C22. I'm sorry. Now let's do C11. C11 is because we are doing this product of A and B. So C11 means the first row of the first matrix. This second one means the first column of the second matrix. So let's write it beside each other. That is -3, 6, 7. And this is 2, 1, 3. So let's multiply that. This one will multiply this. That's -3 times 2. Add it up to the next one. That is 6 and then 1. That's 6 and 1 here. That is 6 times 1. And the last one will be this 7 and 3. That is plus 7 times 3. 7 times 3. So that will be -6 plus 6 plus 21, if I don't make mistake. So that is going to give me 21. So that means in my answer, 21 is here. Now let's do C. Sorry, that should be C2, C1. That should be C12 now. So let's do C12. C12 means this one is the first row. First row. This 2 is the second column. Second column. So that is going to be -3, 6, 1. And the other one is going to be -4, 8, -1. If I don't make it, yeah. Now let's multiply. -3 and -4. That is -3 times -4 plus 6 times 8. I hope you are following. 6 times 8, this 6. The second one, multiplying the second one. 6 times 8. Then 1, this is third one, multiplying the third one, -1. Plus 1 times -1. Okay, that should give me 12 plus 48 okay, 12 plus 48 minus 1, right? Is that not 59 if I don't make mistake? Okay, sorry, this is 7, not 1. 7 times -1, because I was looking at it that it's totally different from the second one. So the first one I did. Okay, so here 5 and that is 53. 53. So the second matrix there is 53 up here, up. Now the next one we'll do is C21. C21 means this C2 here is the second row. Is dealing with row, and this one here is the first column. So that's going to be 1, 0, -1, and then the other one will be 2, 1, 3. Now let's multiply that. That should be 1 times 2 plus 0 times 1, this 0 here, multiply the second one, then plus -1 here, multiply this 3, -1 times 3, okay, equals 1 times 2 is 2, 0 times 1 is 0, -1 times 3 is -3. So the answer is -1 here. So we have -1. Then Anna said, please do C22 for me. And the person got -5. Was it -5 or 5? Okay, let me see. C22, that is 4 times 1 times minus 4. You can even use a hierarchy. 1 times minus 4, 0 times 8, minus 1 times minus 1, that is 1. Okay, minus 4. Are you sure? Let's do it. Let's do it. Because what I'm seeing here is totally different. So let me do C22. For the C22, that is, okay, let me still erase. I think I've not finished erasing what I want to erase there. Okay, C22 now. Based on this 2 is the row 2 of first one. Then this 2 is the column 2 of the second one. Now that is going to give me 1, 0, minus 1. Then multiplying